Have you ever pondered how robots, our futuristic companions, are born? In this era of rapid technological advancement, it's crucial to grasp the science and engineering that breathes life into these machines. We're not just talking about gears and bolts, but a fusion of complex systems. These systems together create entities that can interact with and adapt to our world in ways unimaginable a few decades ago. So, buckle up and prepare to embark on a fascinating journey through time, tracing the evolution of robot manufacturing technology. It all began in the 1950s with the birth of the first industrial robot. In the middle of the 20th century, a new chapter was being written in the annals of technological advancement. This was none other than the dawn of robot manufacturing. The 1950s saw the conception of the first industrial robot, paving the way for a revolution that would forever change the landscape of industries. The initial days of robot manufacturing were marked by a fascinating blend of ingenuity and simplicity. The technology used during this era was quite rudimentary by today's standards, yet it was nothing short of revolutionary for its time. Hydraulics played a vital role in the early stages of robot manufacturing. It was the muscle that powered the movement of these mechanical marvels. The robots of the 1950s were bulky and heavy, primarily due to the hydraulic systems that made their operation possible. These systems allowed the robots to perform physical tasks with a degree of precision that was previously unachievable by human hands alone. But the physical prowess of these early robots was only part of the story. The real magic lay in the basic electronic control systems that brought them to life. These systems served as the brain of the robots, dictating their movements and actions. They were programmed to perform a specific set of tasks, and they did so with an efficiency and accuracy that was truly awe-inspiring. The 1950s was a time of exploration and experimentation in the world of robot manufacturing. Engineers and scientists were continuously pushing the boundaries of what was possible, constantly innovating and improving upon the existing technology. Every new robot that rolled off the production line was a testament to human ingenuity and the relentless pursuit of progress. Yet despite these early successes, the true potential of robot manufacturing was only beginning to be realized. The technology of the time was limited, and the scope of what robots could accomplish was relatively narrow. But the seeds of a technological revolution had been sown. The 1950s marked the first steps in a journey that would revolutionize industries and lives. These humble beginnings would pave the way for the dynamic, multifaceted world of robot manufacturing we know today. This was the dawn of an era that would usher in limitless possibilities, forever altering the course of human history. As we moved into the 1970s and 1980s, technology advanced, bringing significant changes in robot manufacturing. In this era, technology was rapidly evolving, and the world of robot manufacturing was no exception. The core of this evolution was the introduction of microprocessors. These small, integrated circuits brought about a revolution in the field. They allowed for more complex operations, and for the first time, robots could be programmed to perform intricate tasks with a level of precision that was unheard of before. Microprocessors were the brains of these robots, controlling their every movement. They were an integral part of the robot's nervous system, so to speak, receiving input from sensors and sending commands to the motors. But the evolution didn't stop there. Alongside the rise of microprocessors, another crucial development took place: the advent of computer programming. This was a game changer. Programming gave engineers the ability to control and manipulate the functions of robots in a much more sophisticated manner. With programming, robots could be instructed to carry out a series of actions, or even react to different situations. This meant that robots could now be tailored to perform specific tasks in a variety of fields, from manufacturing and construction to healthcare and exploration. The combination of microprocessors and computer programming allowed for a significant leap in the capabilities of robots. Not only could they perform more complex tasks, but they could do so with greater precision and efficiency. The days of robots being simple, single-purpose machines were long gone. In the 1970s and 1980s, we also saw the emergence of the first industrial robots. These were large, powerful machines designed to take on heavy-duty tasks in factories and warehouses. They were capable of lifting heavy loads, performing repetitive tasks tirelessly, and working in environments that were dangerous for humans. In essence, the advancements of the 1970s and 1980s were pivotal in shaping the world of robot manufacturing as we know it today. They paved the way for the next generation of robots, ones that could think, learn, and adapt. These advancements laid the groundwork for the next major leap in robot manufacturing. The dawn of the digital age ushered in a new era for robot manufacturing. As we journeyed from the 1980s into the 1990s and beyond, the digital revolution set the stage for a paradigm shift in the world of robotics. This was not merely a change in the tools we use to build robots, but a fundamental reimagining of what robots could be and do. At the heart of this revolution was the introduction of artificial intelligence, or AI. No longer were robots simply machines that could perform pre-programmed tasks. Now, they were capable of learning, of adapting to new situations, of making decisions based on the data they collected. This was a game changer. It meant that robots could improve their performance over time, learning from their mistakes and becoming more efficient and effective in their tasks. Alongside AI, the digital revolution also brought with it the field of machine learning. Machine learning is a subset of AI that focuses on the development of algorithms that allow computers to learn from and make decisions based on data. This meant that robots could now learn from their experiences, adjust their actions accordingly, and even predict future outcomes based on past data. This combination of AI and machine learning led to the creation of autonomous robots. These robots could operate without the need for human intervention, making decisions and solving problems on their own. They could navigate complex environments, recognize patterns, and even learn to perform tasks they were not initially programmed to do. But the digital revolution didn't stop there. It continues to evolve, pushing the boundaries of what is possible in robot manufacturing. Today, we're seeing the development of robots that can interact with humans in more natural and intuitive ways. Robots that can understand and respond to human emotions, and robots that can collaborate with other robots to complete tasks more efficiently. The digital revolution has brought us to the cutting edge of robot manufacturing, with innovations still unfolding. Today, we stand on the precipice of a future dominated by robots. A statement that's not as far-fetched as it may have sounded a few decades ago. The current state of robot manufacturing technology is nothing short of awe-inspiring. It's like a scene straight out of a science fiction novel, yet it's our reality. The robots of today are a far cry from their clunky, rudimentary predecessors. They're sleek, efficient, and increasingly sophisticated thanks to advancements in various technologies, and the technology behind their manufacture is advancing at an equally impressive pace. One of the most exciting trends shaping the future of robot manufacturing is nanotechnology. Imagine robots so small they could fit inside a human cell, capable of performing medical procedures from within the body. This isn't just theoretical. Scientists are already making strides in this field, bringing us closer to a future where nanobots are a common part of healthcare. Then there's 3D printing, a technology that's revolutionizing manufacturing as we know it. With 3D printing, we can create complex robotic components with ease, accelerating the production process and opening up new possibilities in robot design. It's a technology that's not just changing how we make robots, but what we can make. And let's not forget the Internet of Things, or IoT. This technology is enabling our robots to connect and communicate with other devices, creating an interconnected network of smart, autonomous machines. The implications of this are vast, from robots that can adapt and learn from their environments, to entire factories run by a network of intelligent machines. These trends and many others are shaping a future of robot manufacturing that's as thrilling as it is uncertain. It's a future filled with potential, where the boundaries of what's possible are constantly being pushed. As we gaze into the future, we can only imagine the technological marvels that await us in the field of robot manufacturing. Our journey through the evolution of robot manufacturing has been enlightening. We began our expedition in the dawn of robot manufacturing, where we saw the first mechanical hands take shape. The brilliance of human ingenuity was evident as we witnessed the birth of a concept that would forever change our world. As we moved into the 1970s and 1980s, we experienced an evolution. The era of automation had arrived, and with it came the ability to perform complex tasks with precision and consistency. The robots of this period were not just tools, they were the harbingers of a new era. Then came the digital revolution, a time of rapid technological advancements that would set the stage for the future. This was the period where the integration of software and hardware brought about a new level of sophistication in robots. They were no longer just mechanical devices, they were becoming intelligent. In the present, we see robots as integral parts of our lives. From manufacturing plants to our homes, robots play a significant role. Looking into the future, we can expect even more. With advancements in artificial intelligence and machine learning, the robots of tomorrow will be even more intelligent and capable. In closing, we've traveled from the birth of robot manufacturing to the sophisticated world of today, while also casting an excited gaze into the future. As we continue to push the boundaries of technology, who knows what the future holds for robot manufacturing?